In this video, we want to look at the periodic table and how it's organized. So here we see a periodic table. So what we're going to talk about are the different types of elements that we'll be seeing on the periodic table. How are things arranged horizontally and vertically on the periodic table, as well as why the periodic table doesn't have that perfect square or rectangle shape. When you're looking at this, you're going to see that it's not a perfect square or a rectangle. It kind of has this odd and peculiar shape to it. These are some of the things we're going to talk about in this presentation. The first thing we want to look at is grouping elements on the periodic table into three main categories. And you see these three main categories on this periodic table: the metals, the metalloids, and the nonmetals. What you want to notice is that the metals are the biggest part of the periodic table. These are the ones that are shaded in blue on this periodic table. They're kind of in the middle and on the left hand part of the periodic table. Your nonmetals, those are those shown that in green on this periodic table. Those are the ones that are in the upper right hand part of the periodic table. And then between the metals and the nonmetals in the orange color are the metalloids. So we want to go through and talk about each one of these groups of elements. So the periodic table can be organized by what type of element you are looking at. And the first one we want to look at are the metals, because these are probably the ones that are most common to us. These are ones that you're probably most familiar with. Our metals are located on the middle and the left-hand part of the periodic table. And when we think about metals, usually when we're thinking about metals, metals are often solids at room temperature. We're kind of familiar with that. Metals also generally are shiny in appearance, especially when there's no coating on them or they haven't reacted with anything. They tend to be very shiny in appearance. Think about a brand new penny, a new coin, a gold ring. They tend to be very, very shiny in appearance. Metals tend to be very workable. Now, what does that mean? That means it's pretty easy to shape metals into the specific sizes, shapes, dimensions that we want in order to build things out of. They tend to be both very malleable. So malleability means that they can be pounded into very, very thin sheets. They also tend to be very ductile. Ductile means they can be pulled into thin, long wires. Metals tend to be very good conductors of both heat and electricity. You're familiar with them being good conductors of electricity. They're used for wires in all sorts of electronic devices. They're also good conductors of heat. You're familiar with this as well. Think about your seatbelt buckle on a hot summer day. When you just get into your car, they heat up very, very quickly, metals. That's why that seatbelt buckle is so hot when you get in it on a warm, sunny summer day. They also will cool down very quickly as well. Those are all the physical properties that you would associate with metals. There's also some chemical properties we want to talk about. And the main chemical property we want to deal with is how they deal with electrons. Previously, we've talked about electrons being the currency in chemistry. Those are the action items in chemistry, are those electrons. So how will metals deal with electrons? Well, metals will tend to lose electrons. Now, if we remember, electrons are negatively charged. So when you remove a negative charge, the end result, if you get rid of a negative, you're going to be positive. So these will form positive ions. If we compare metals with nonmetals, this is a very useful kind of term. We may not be as familiar with nonmetals, but just in what we name that category, nonmetals. That literally means not metals. So we're expecting some of the exact opposite properties that we saw with the metals for our nonmetals. For our nonmetals, we're looking at these being on the upper right-hand side on the periodic table. Our nonmetals will have both solids, liquids, and gases at room temperature. Pretty good representation of the different states of matter. Remember that our metals tended to be shiny in appearance. Our nonmetals will be very dull in appearance. They also tend to not be very workable materials. It's very tough to work with them in terms of manufacturing them into specific dimensions, sizes, shapes. Now, a lot of them are gases. That's very tough to make gases workable into specific sizes and shapes. But even the solids tend not to have the same structural integrity that you find with metals. The solids in our nonmetals tend to be kind of powdery or brittle solids that make it tough for them to be worked into the exact sizes and shapes that we might desire. Nonmetals are also poor conductors of heat and electricity. They don't conduct electricity very well. They don't conduct heat very well either. So a lot of the exact opposite physical properties for the nonmetals compared to what you saw for the metals. Our nonmetals will also have the opposite chemical properties as well. Metals tended to lose electrons to form positive ions. Our nonmetals will gain electrons to form these negative ions. If we kind of look at that, what forms in between metals and nonmetals on the periodic table, those are the metalloids. These are located between the metals and the nonmetals on the periodic table. They have some of the same properties of metals and nonmetals. They're kind of that in between. They are semiconductors. They don't conduct really well, but they don't not conduct either. Some of them can be shiny. Some of them are dull. They are kind of in that in-between land. Some of them will form positive ions, others negative ions. They're kind of that in-between land between the extremes of metals and nonmetals. So kind of looking at the periodic table again, not only will those metalloids be between the metals and the nonmetals in terms of their physical and chemical properties, but also due to their location on the periodic table. You see they're kind of located between the metals and the nonmetals. So that was one type of organization, organizing by metals, nonmetals, and metalloids. There's another type of organization we can go through. Periodic tables also organized by periods and groups. We'll start with the periods. Our periods are the horizontal rows that you're seeing on the periodic table. And if we just kind of go down, period 1, period 2, period 3, 4, 5, 6, and so on. These are the horizontal rows. We don't call them rows, we call them periods. We won't spend much time on the periods. What we'll spend more time on are the groups. The groups are the vertical columns that you see on the periodic table, except we don't use the term columns, we use the term group. Sometimes you may also see the older term families for this. And there's two different ways of numbering the groups on the periodic table. One way that you see is just going right across 1, 2, I'm highlighting these in yellow, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 across. This is the more newer, modern way of organizing the groups on the periodic table. But here's a case that even though it's a little bit more new and modern, no one actually ends up using that way. Everyone still uses the older technique with the A's and the B's that I'm going to highlight in green. 1A, 2A, across the middle are all these different B's, Then when you get back to the right-hand side of the periodic table, you get 3A, 4A, 5A, 6A, 7A, and 8A. We're going to use the older group numbering because what we'll see in future units is if you use the older group numbering, you get access to some useful, important information right away by doing that. We want to talk a little bit more about the groups than we did the periods because it's the groups that end up giving us this kind of unusual shape on the periodic table. Periodic table is really organized by the groups. Elements that are in the same group will have similar chemical properties. So if we look on that first group, group 1A, hydrogen, lithium, sodium, potassium, rubidium, we're looking at all these elements in this first group that I'm highlighting in yellow. That means that there's some similarities between those. They have similar chemical properties. They belong to the same group, the same family. So that's why the periodic table is not a perfect square, not a perfect rectangle, because we're organizing things such that if they're in that same group, there's going to be some common chemical features between them. So just some things we talked about while looking at the periodic table. The periods are the horizontal rows on the periodic table. The groups are the vertical columns on the periodic table. We saw the two different numbering systems for the groups. The older system that uses the A's and B's, sometimes instead of numbers, they'll often use Roman numerals as well. And the newer system that just goes 1 through 18. As we talked about already, we're going to be using the older system as that provides direct, useful information that we'll see later in the course. Elements in that same group have similar chemical properties again. And it's that reason why the periodic table isn't a perfect square or a perfect rectangle, because of the organization by groups. Now, some of those groups, besides being numbered specifically, have common names that we want to be familiar with. So I just want to quickly kind of go through these common names and properties. For right now, we're going to just focus on the names. I'm going to mention the properties, and the properties are going to be what ions get formed. These aren't going to be needed right now, the ions of what get formed, but you'll see in a little bit, in a couple chapters, we're going to be using that information of what ions get formed. So let's start with group 1A. Group 1A does have a common name. Those are the alkali metals. So we need to be familiar with that name because that name comes up and is commonly used to describe that group. And the chemical feature that we'll see in future units that we're going to use is these will form +1 ions. Group 2A does have a common name that we need to be familiar with. These are the alkaline earth metals. And that common feature that we're going to use in the future is that these are going to want to form +2 ions. Now, all of the B's, these are the things you're seeing in the middle of the periodic table. We kind of group all of them together and call them the transition metals. So these often get grouped together. They're metals, so they'll form positive ions, but what we'll see with these transition metals is they'll form positive ions, but of a lot of different charges. You can't kind of pin them down to one specific charge. So we keep on going. Once we get through all the transition metals in the middle of the periodic table, we pick up the A's, group 3A. All of these groups technically have names, but if they're not commonly used, there's no point in memorizing them. No commonly used name, so we don't have to worry about that, but their common chemical feature usually will form +3 ions. Group 4A, again, no commonly used name, but these will usually not form any ions. Occasionally they will, but for the most part, you want to associate this group with no ions formed. Group 5A, next group over, again, no commonly used name. These will usually end up forming -3 ions. Notice that we're starting to get over to the right-hand side of the periodic table. We're kind of through with the metals. We're starting to pick up the non-metals. So now we're seeing negatively charged ions being formed here. Group 6A, again, no commonly used name, but usually you're going to see -2 ions coming from that group. When we get over to Group 7A, Group 7A does have a commonly used name that we want to make sure we're familiar with. These are the halogens, and that common chemical feature of the halogens is they will usually form -1 ions. The last group all the way on the right, Group 8A, does have a commonly used name that we need to be familiar with. Those are the noble gases, and their common chemical feature is no ions. That term noble gases kind of hints at that. Noble is kind of used in that old English style of, noble, inert, unreactive. These aren't going to form any ions. Again, for right now, what we need to be concerned with are just the group numbers and the names that are used for them. Things like the ions that are formed, whether it's +1, +2, +3, we won't use them right away, but in the future, we'll be using that information a lot. So here you just see the periodic table again in terms of everything we just talked about. So when we look at two elements, if I look at group 2A and I look at magnesium and calcium, the fact that they're in the same group, those alkaline earth metals, that's telling me that they're going to have similar chemical properties. And the chemical property that we talked about that we'll be using in the future is +2 ions. But for right now, we're just going to focus on the organization, the group numbering, and the specific names that are used to describe those most common groups.